In this video, we're going to examine the behavior of a projectile using a special feature of LoggerPro called video analysis. So first, let's run the movie and see what's happening here. You notice there's a ball on top of the table. Well, not very exciting, but this is an example of a projectile. Once the ball leaves the table, then it has become a projectile. What we're going to do here is literally analyze or evaluate the motion one frame at a time. Now, in order to do this, the program needs to know distances on the picture. So the scale has been set up that from here to here has been created is 1 meter. So we have a proper scale now. I'm going to click on this button right here, this red dot, and that's going to allow me to track the points. Now what's going to happen is I'm going to follow this motion frame by frame all the way down, and while it's doing that over here on this graph, it will be showing position time data, both horizontally and vertically. So let's get started. So all I do is put my cursor right here, try to put it right here in the middle of the ball, click, and you'll notice, very faint here, sorry about that, but there's a dot here. Also a dot has been created here, both horizontally and vertically. And the frame advanced 1, so I'm going to click again. And so this is a little tedious, but I'm just going to try to follow the ball. Now right now, of course, the ball is not a projectile, because the definition of projectile is two-dimensional motion in which the only force acting on the object is the force of gravity. Well, right now, of course, this ball is experiencing not only the force of gravity, but also a normal force from the table. So that disqualifies it from being a projectile at this moment. Just a quick glance at the graph, and we notice here the red is the horizontal movement, and so far you notice that this is a perfectly straight line, and since this is a position time graph, we know that the slope of a position time graph is a velocity. So right now the slope of this line would be the horizontal velocity, and up here we have the vertical position over time, and the slope of this line would be 0. So not surprisingly, the object has 0 vertical velocity at this moment. Well, let's continue. At this moment, I think right now something has changed. Obviously, the ball is no longer touching the table and is simply under the influence of gravity. Now, a projectile, the way we do our problems is that we assume no wind resistance. Well, that's not very reasonable if you're moving extremely fast, but this ball is not moving fast at all, just getting started. It's small, and so honestly there's very little wind resistance. It's a good assumption. Let's track it all the way to the ground. Alright, so now just watch the movie again, and this time you can watch the motion of the ball, and we're going to learn that this shape actually should look familiar. This looks like half of a parabola, and that is the shape of any projectile. It is parabolic. The name for the shape is called the trajectory, and all projectiles have a parabolic trajectory if they're under no wind resistance, only gravity's influence. Well, let's look at this graph over here. Well, you can see very clearly from the vertical position graph, you can tell exactly when the ball became a projectile, because for all this time it had no velocity, and now it has a velocity. We also notice that this motion is curved. It is parabolic. We remember that means that it is accelerated motion. Meanwhile, if you were just looking at the red data, the horizontal position data, you can't tell when the ball left the table. In fact, that is the key idea here with a projectile. What happens horizontally is completely independent of what happens vertically. Horizontally, there was no change. essentially horizontally, the ball never knew it left the table. Its speed never changed horizontally. That's zero acceleration. So that's one of the most important points about projectiles, is that horizontally there is no acceleration. But vertically there certainly is. There is an acceleration. This thing is changing velocity. So in fact, a good idea is let's change this to a velocity time graph. So let's look at the x velocity and the y velocity. Now my title is wrong, but here we can see that basically with a little statistical variance here, this is the one horizontal velocity. Here was when the object was on the table. It had zero vertical velocity, but now through here we see a changing velocity. And it's becoming more and more negative because it was dropping. So if we find the slope of this, and you should remember that the slope of a velocity time graph is the acceleration. So let's find the slope of this. And we'll look at the y information. Well, we shouldn't be surprised by this number. It's telling me that the slope of this velocity time graph is negative 9.74. That's actually very good data. We were expecting that. The acceleration in the vertical direction should be negative 9.8 if we're on the surface of the Earth. So actually our data is very good for proving the fact that in a projectile motion, the only force acting on the object is the force of gravity in the down direction. And the main idea about projectiles is that force in the down direction has no effect on the motion in the horizontal direction. So when we do our problems, we're going to find that we just simply split our work into two parts. We do the horizontal information and we work with the vertical information, but we keep them separate because they do not affect each other. And what equations will we use? Well, since this looks just like the kinematic stuff we did before, and so therefore we'll be using the same equations we've already been using since pretty much the first month of school. So you should feel very comfortable with the equations that we're going to use with projectiles.